Assalamualaikum. Today I'm gonna present about our project, which is Industrial Basecamp Project, and the subject BMIM 2123 Multi-Axis Machining. So my name is Azamuddin bin Muhammad Nizam. So for our introduction, computer aided design, which is CAD, and computer aided manufacturing, which is CAM, are important technologies in modern manufacturing. CAD is used to create a 3D model, while CAM is used to generate CNC machining toolpath. These technologies improve machining accuracy, reduce production time, and minimize errors through simulation before actual machining. So for our project overview, in this project, CATIA V5 was used to design and simulate the machining process of a locating finger. The machining operation included pacing, surface, roughing, profile contouring, pocketing, multi-axis plane contouring, and multi-axis sweeping. The machining simulation was used to verify the toolpath were accurate, collision-free, and able to produce the required part. For our methodology, the project begins with creating a CAD model of the locating finger in CATIA V5. Next, the stock material and machine coordinate system, which is MCS, are defined. After that, cutting tools are selected and machining operation are programmed. Finally, toolpath are generated and the entire process is verified through simulation.
Good morning everyone, my name is Azri and today I will present our project. I will explain the process flow of the machining process. This slide shows the overall process flow of our project. First, we create the CAD model and define the stock material. Next, we set up the workpiece and machine coordinate system. Then, we selected the cutting tool and generate the machining tool part. After that, we run the machining simulation to check for any error. Finally, we verify the final result to ensure the CAD match the original CAD model. This slide explains the project design operation. First, we create the CAD model in CATIA V5 based on the engineering drawing. Next, we define the stock material and set the machine coordinate system, or MCS. Finally, we set up and clamp the workpiece securely on the fixture to ensure stability and machining accuracy during the machining process. So this slide shows the cutting tool and operation used in this project, with one base mill and several end mill with different diameters, such as 60 mm, 10 mm, 9 mm, and 6 mm. Each tool has a specific function, including facing, roughing, pocketing, profile contouring, finishing, and multi-axis machining. Choosing the right cutting tool helps improve machining accuracy, efficiency, and surface quality. This slide explains the facing operation. We use a 50 mm face mill to machine the top surface of the workpiece. The facing process creates a smooth or flat reference surface, which is important before performing the next machining operation. This helps improve machining accuracy and ensure the quality for final project. This slide explains the roughing operation. The 60 mm end mill was used to remove most of the excess material from the workpiece. A zigzag toolpath was selected because it removes material efficiently while maintaining safe tool movement. This operation prepares the workpiece for the finishing process and improves the overall machining efficiency.
Hi, Assalamualaikum. My name is Muhammad Nurul Hafiz. I'm from BMIM student. So today I want to talk about 4 process. Okay, the first one is profile contouring and pocketing, and the third one is multi-axis flank, and the fourth one is multi-axis sweeping. Okay, let's move to the profile contour process. Okay, for the profile contour process, we use a 10 mm end mill with machining step-over and finishing parameters, while the macro management controls safe tool movement to generate a accurate contour toolpath. For this process, we use 2 finishing setup. So it's mean like the first one is semi-finishing and the last one is finishing to ensure a smooth surface like that. Okay, let's move to pocketing process. So for the pocketing process, we use a 6mm end mill with machining step over and finishing setting, while the macro management provides safe tool movement to create accurate internal pocket feature. Okay, for the third process is multi-axis flank. So for this process, we used to do chamfer on our project. The diameter of the end mill is 6mm, which machining step over finishing and third axis setting, while the micromanagement controls safe movement to machine complex inclined surfaces accurately. Okay, for the last process is multi-axis sweeping. Okay, for this process, we use on the complex surface and the diameter of the tool is 10mm and mill with machining radius and tool axis setting, while the macro management adjusts safe tool movement to achieve a smooth finish on a complex curved surface. So basically, for the process, we use two times. The first one is for semi-finishing and the last one is for finishing, because we want a good surface. Okay, for the part result and discussion, we already do the final simulate workpiece. So after completing all machining operation, the final simulate workpiece was produced successfully. All required features such as the curve surface, pocket and inclined walls and hole were machined correctly. The smooth surface finish also showed that the machining parameters were selected properly. So that's all for me. Thank you so much.
Nama saya Ali Adrana. So saya akan present result and discussion for final simulation workpiece. After completing all machining operation, the final simulation workpiece was produced successfully. All required features such as the curved surface, pocket, inclined wall, and hole were machined correctly. The smooth surface finish also show that the machine parameters were selected properly. Next is the result. You can see from the picture, we have before and after. This comparison show that the final simulation workpiece is almost identical to the original CAD model. All important features were successfully machined and no significant dimension difference were observed. So next is video simulation. Lastly, conclusion. For the conclusion, the CAM programming was successfully complete using CATIA V5. Accurate toolpaths were created and the machining simulation ran successfully without any collision. The final machine part matched the CAD model, which with good surface finish and accurate dimension. These results show that CATIA V5 is an effective software for multi-axis CNC machining. That's all. Thank you.